Okay, so here's a question. A canoeist is rowing on the Vaal Dam at a velocity of 4 meters per second in a northerly direction. So we know that this is a vector. It has magnitude and direction. A wind of 3 meters per second suddenly starts blowing, so magnitude, in a southeasterly direction. Okay, so we have two vectors. Calculate the resultant velocity of the canoe in magnitude and direction. Okay, so step number one is we want to draw a vector diagram. So the first one is we'll have the canoeist in a northerly direction at 4 meters per second in a northerly direction. And a wind starts blowing in a southeasterly direction. Okay, remember for vectors we always use the head to tail method. So from the top of the canoeist's vector in a southeasterly direction, so that means it's down this way, at 3 meters per second. We want to find the resultant. So the resultant vector must be here. We want to calculate the green, so we want the magnitude in meters per second and the direction. Now there's several ways that we can solve this. We can solve it by resolving each of the given vectors into horizontal and vertical components. We can add and subtract them and then arrive at the answer. Or we can use our new tool, complex numbers. I'm going to do it with complex numbers. So let's do for the canoeist. So the canoeist, he has a magnitude of 4 and he's at an angle of 90 degrees. Remember, in mathematics, we always measure from the horizontal in an anti-clockwise direction. So if he is traveling in a northerly direction, it means his angle will be 90 degrees. The wind is blowing with a magnitude of 3 at an angle of, they say southeasterly. Southeasterly is here. So 180, this is 270, 45, if it's in a southeasterly direction, that gives me a total, 270 plus 45 is 315 degrees. So what do? We're going to call up our calculator. Calculator is called up. Let's bring it into screen here. Make sure your calculator is in degrees. If it's not in degrees, it won't work very well. Okay, so we'll enter the first vector of the canoe, and that is 4 at an angle of 90 degrees. And the second vector is 3 at an angle of 315 degrees. Okay, now we just add them. And there we have our answer. Let us view the answer not in rectangular, we want it in polar coordinates. So the answer is, the resultant is equal to 2.83 at an angle of 41 degrees. 2,83 at an angle of 48,5 degrees. Let's interpret our results from the complex numbers. The magnitude is 2,83 meters per second. In the direction, 48,5 degrees from the horizontal. Done. If we wanted to give it in a bearing, then we would just say 90 minus the 48 and we would get the bearing of 41 point whatever degrees. And that's it. Okay, let's move on to the next question.